Morning.
Good morning.
Morning, sir. Good afternoon, sir.
Good afternoon. Good afternoon. So let us start. Yesterday we were talking about the necessary and sufficient condition for maxima and minima for a function of two variables. So we had seen that what are the conditions for the maximum to occur. Now next we shall be talking about the condition when at a given point x naught y naught this function is minimum. So for that, actually this condition needs to be satisfied that rt minus s square is greater than 0 and r is greater than 0. In that case, what will happen? That the functional value at x0 plus h and y0 plus k means in the neighborhood of the point, the point is f at x naught y naught, this will be greater than this. So the points which are surrounding this point, the neighboring points are having higher values than this point. So therefore, we will get in that case delta f will be positive then in that case, and therefore this function value will be minimum, okay, at a given point. So this is the condition when you have minimum. If this condition is satisfied, rt minus s square greater than naught, greater than 0, and r is also greater than 0, that means that the point surrounding this point, which is under consideration, these points will have, all these neighboring points will have higher values as compared to this one. So in that case, delta f will be positive, and then the function is having the minimum value at that point. So we have found out minima at this condition. Now, if rt minus s square is less than 0, okay, then delta f could be either positive or could be negative depending on sign of h and k. So whether h is positive or negative, h and k are positive or negative, depending upon that, this delta f could be greater than 0 or delta f could be less than 0 in this condition, when this condition is satisfied. So we shall not be able to determine whether it is maxima or minima, or in other words, we will reach a settle point. So that will be the condition for the settle point. That we cannot say that this is maximum or minimum. In one direction it will be maximum. In other direction it will be minimum. So in that case we shall obtain a settle point. Up to this, any problem?
No, sir.
All right. So the next is that failure case. When it all fails,
It will become 0.
then it will become zero. Yes. Failure case is when RT minus AC square is equal to 0. Then in that case, we shall not be able to determine maxima or minima. Okay, we shall not be able to determine maxima or minima. And in this case, further investigation is required. Now we'll have to find out the other ways to determine this maxima or minima. Okay, so all in all, these are the four sufficient conditions. So in one case we can find out maxima, in another case we can find out minima, in one case we can find out settle point, or we cannot find anything. So these four cases are there. I hope all these are clear to you all.
Yes, sir.
Yes, sir.
All right. So now let us talk about some problems. Let us talk about some problems. So one of the example I am taking over here is that we have been given a function. Now that function is 4x square plus 4y square plus x cube y plus xy cube minus xy minus. So this is the function. It has been given to us. We have to find extremum. Extremum means we don't know whether it is maximum or minimum, but we have to find out that extremum. So those points we have to find out where the functional value will be maximum or minimum. Okay. So in order to do so, first of all, we have to differentiate this. So if we differentiate it, we will get 8x plus 3x square y plus y cube minus y. Is it okay?
Yes, sir.
Yes, sir.
Similarly, if I want to find out fy, that will be 8y plus x cube plus 3xy square minus x. Hmm? And
Minus
because
1.
from this we will find out the stationary point, the critical
Sir,
point.
minus 1.
Huh? Minus
Minus 1
1.
we have left. Sir, in
Here.
last one, sir,
No.
xy minus y, we are differentiating with respect to y, so it will be
No, this
minus
is
1.
4.
Acha,
4.
oh, okay,
4.
sir. Okay.
4. Huh? This is 4. Huh? So this is what we will get. Hmm? So now, in order to find out x and y, we add equation 1 and equation 2. So after adding and simplifying, we will get x plus y into x plus y whole square plus 7 equal to 0. So now either it will be x plus y equal to 0 or x plus y whole square plus 7 equal to 0. Obviously, we cannot find out real number from this, right?
Yes,
From
sir.
this one. Right. So only option left is that x plus y is equal to 0. That is from this y equal to minus x. So now, in order to find out the points, let us put back this value in any of these equation, equation 1 or equation 2. So let us put in equation 1. So 8x minus 3x square, sorry, x cube, 3x cube minus x cube plus x equal to 6. Okay, what I have done, I have put this in this equation. Any of this equation I can put. Okay, so from this actually we will get 9x minus 4x equal to 0. Or x equal to x into 4x square minus 9 equal to 0. Fine. If we solve it, I can write it like this. Now from this, what we will get, x is equal to 0 and x is square is equal to 9 by 4. Okay, either this will be 0 or this will be 0. If this is 0, then x is equal to 0. If this is equal to 0, then x square is equal to 9 by 4. Or from this, x is equal to plus 3 by 2 or minus 3 by 2. So we have obtained x values, and because y is equal to minus x, so we can put over here. So we will get y equal to 0. If I put 3 by 2, so it will be minus 3 by 2, and if I put minus 3 by 2, it will be 3 by 2. So we got stationary points or critical points. Okay, we got stationary points. And these stationary points are 0, 0, because when x is equal to 0, y is equal to 0. Okay, next is when x is equal to 3 by 2, y is equal to minus 3 by 2, and when x is equal to minus 3 by 2, y is plus 3 by 2. Alright, so stationary points we have been able to determine. I think there is no issue till now.
Yes, sir.
No, sir.
Alright, so now what I need to do, I need to differentiate this and this in order to, with respect to x and with respect to y. So I get it 8 plus 6xy. This is the double differentiation of f with respect to x. And double differentiation of y with respect to x is 8 plus 6xy.
6x.
Okay. And any of them can be differentiated, this one with respect to y or this one with respect to x, in order to obtain fxy. So what this fxy will be? If I differentiate, for example, this with respect to y, so this will be 0, this will be 3x square plus
Plus 3y square
minus 1,
6x.
minus 1,
minus 1.
right?
Yes, sir.
So this is what I will get. This is r, this is t, and this is s. Isn't it?
Yes. Yes, sir.
So So now RT minus S square is, then let us see at different points. So first we will try at 0 0. Okay. So RT minus X square is R is at 0 0, it is 8. Okay, put value of X equal to 0, Y equal to 0. So this will be 8. T is again 8, isn't it? And XY is, this is 0, this is 0, so minus 1. So minus 1
Minus one.
square. ठीक है? So this will be 63. Is it positive? Yes, it is positive.
Yes, sir.
But apart from this, R is also
Positive.
positive. Okay, because it is equal to 8, which is positive. So it means that F should be minimum
Minima
at
0,0.
0 0. Okay, so we have found out that this is at 0 0, the value of the function is minimum. Okay, this is clear up to this. Is it clear?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Okay. The next is that we have to find out now at 3 by 2 and minus 3 by 2. So at 3 by 2 minus 3 by 2, what will be RT minus X square? R will be 8 minus 6 into 9 by 4. Is it okay? 8 minus 6 into 9 by 4. 3 by 2 into minus 3 by 2. So minus 9 by 4. Okay. So this is 3, this is 2. So this will be minus 11 by 2. Huh? This will be your R. T is also equal to the same thing. So T is also minus 11 by 2. And S will be equal to 3 into 9 by 4 plus 3 into 9 by 4 minus 1. So this will be 50 by 4. That is 25 by 2. Is it okay?
Yes, sir.
Alright. So RT minus S square will be 121 by 4, 11 by 2 into 11 by 2, and minus minus plus. So 121 by 4 minus S square means 625 by 4. Is it positive or negative?
Negative, sir.
It is negative.
Negative.
So since it is negative, so then we cannot find out that whether it is maximum or minimum. In other words, we have arrived at
Saddle point.
settle point. So here we will get settle points at 3 by 2 and minus 3 by 2. Similarly, if you do it with minus 3 by 2 and plus 3 by 2, y equal to plus 3 by 2, once again you will end up with this particular result only. So if it is plus minus and minus plus, means when plus 3 by 2 is there, here it is minus 3 by 2. When it is minus 3 by 2 here, it is plus 3 by 2 here. So then also we will get the same thing, isn't it? We will arrive at the same conclusion. So it means at these points, it is saddle point, and at 0 0, a functional value is
Minimum.
minimum. So that is
Minimum.
what we found out. Any questions up to this? Any questions?
No, sir.
No, sir.
No? Okay. So this is clear. Okay? So now,
सर
yes.
सर आरटी माइनस एस स्क्वायर नेगेटिव है तो उस पे हम मिनिमा और मैक्सिमा के लिए कुछ नहीं कह सकते.
नहीं कह सकते ना, तो सेटल पॉइंट है. वो एक डायरेक्शन में मैक्सिमम होगा, दूसरे डायरेक्शन में मिनिमम होगा.
बोथ होगा ना.
हैं?
तो उसमें तो बोथ होगा ना, मैक्सिमम मैक्सिमम भी होगा, मिनिमम भी होगा।
इसीलिए तो मैं बोल रहा हूँ, एक डायरेक्शन में मैक्सिमम होगा, दूसरे डायरेक्शन के लिए मिनिमम होगा.
यस।
So that is actually your settle point. I hope it is clear.
ओके
Yes, sir.
सर।
Yes. All right. So one more problem. Let us see. Let us see another problem. Our problem is that we have been given a rectangular box. Okay, we have been given a rectangular box. Now, the volume of this box is, or what it tells you, that capacity of the box is 32 cubic feet. All right, the capacity of this box is 32 cubic feet. But one thing is there, that in this box, this top is open. So you have a box, say you have a carton. What you do, you remove the top portion. So you have five sides: one, two, three, four, and this. Okay, these five are there, and this one is cut open, right? So now, actually, what we have to determine is that we have to determine the yes, determine the dimensions of the box so that the surface area is minimum. Okay, we have to determine the dimensions of the box so that the surface area of this box is minimum. How many sides are there intact? Five.
Five.
Top one is open. Okay.
Yes sir.
So this is what we have to make, this kind of box. Let us see. So now already it is given to us that volume is 32 cubic feet. So if I say that this direction, this is x, this is y, and this is z. In other words, if this is x, this is y, and this is z. Okay. So what will be the volume of this one? X, y, and z. Huh?
Yes, sir.
And this is equal to 32 cubic feet, right? Already given in the question. So z is equal to, let us say, 32 by xy. Can I write down it like this?
Yes, sir.
Yes sir.
All right. Now, if I look at the surface area, so what will be the total surface area of this box? So xy is 1, x into y is for this particular surface. Okay. Plus similarly 2yz, right? 2yz and plus 2z. Is it okay?
Yes.
Yes, sir.
Yes, sir.
All right.
Yes sir.
So, so this is what you will get. So now this will be the total surface area of this box. Now this we have to minimize. So we have obtained an equation for this one. Now we have to see that what will be the value of x and y such that the surface area of this box is minimum. So what I do, I take the first derivative of this. Okay, I do one more thing before this. I put value of this z in this one. So this will be 64 by x, and if I put z over here, then it will be 64 by y. This is equation number 2. No problem. From equation 1, I have put the value of z in equation number 2. So I have removed z altogether. Okay, clear?
Yes, sir.
Yes, sir.
Okay, all right. So now this r, that is sx, the first derivative with respect to x. What we will get? Y minus 64 by x square. Huh? And what will be t? T will be sy. That will be x minus 64 by y square. Is it okay?
Yes,
Yes,
sir.
sir.
Yes, sir.
All right.
सर
हाँ, yes.
सर x कैसे निकाले हम?
किसका x कैसे निकाले हैं?
s s s
s कैसे निकाले हैं?
नहीं सर s.
हाँ, ये s कैसे निकाले हैं?
हाँ हाँ
अच्छा, ये बॉक्स है, जस्ट this is a rectangular box.
yes sir.
Huh? So I am considering that this is y and this is x. Okay. So what is the surface area of this plane? X into y.
yes sir.
Simple. On top side it will also be x into y,
x into y.
but top side is missing.
yes sir.
So xy.
okay sir.
Similarly, I can find out other two directions also.
okay sir.
So this will be what?
xy yz.
Ha, right? And this will be
zx.
zx, and they are having two sides. Okay.
okay sir, तो 2yz plus 2zx.
ठीक है? I think now it is clear.
yes sir.
Okay, so now I have got this. This, sorry, not R. It's not R. This is not R. This is Sx. Okay, and this is Sy. So this is equal to 0 and this is equal to 0. Right? So it means y is equal to 64 by x square, and from this x is equal to 64 by y square. Anything we can put x or y in these equations. Alright, we can put, if you put y over here, then we get x. So we can put it. X is equal to 64 by 64 by x square whole square. So this will be 64 by 64 into 64 into x to the power 4. So this is gone. So x to the power cube is equal to 64. Is it okay? एक x से x इधर कट जाएगा तो x क्यूब बचेगा. x क्यूब is equal to 64 है? और
Yes, sir.
it means x is equal to 4. Right?
Yes, sir.
And we can put this value over here. So 16, so y also comes out to be equal to 4. All right.
Yes, sir.
So now we have got, huh? This is okay. So we have got x is 4, y is 4, and z is equal to
2.
okay. These all are in feet. Okay, remember these all are in feet. Okay. So this is what we have got. We have got stationary point. So first of all, we have to find out that where is the stationary point, and then we will further investigate whether it is maximum or it is minimum at these points. Now next is we have to find out R. R is x. So what you will get if you differentiate it with respect to x, we will get 128 by x to the power 3. Is it okay?
Yes, sir.
And similarly, we will get t is equal to syy. That is also 128 by y. ठीक है? And s is equal to s xy. So whether I differentiate this with respect to y or this with respect to x, what I will get? If I differentiate it with respect to y, I will get 1.
1, sir. 1.
1. Or with respect to x, I will get 1. So
1.
this is what I have got. So once I have got this, then next thing is RT minus S square. So that will be 128 by x cube into 128 by x cube minus 1. Sorry, y cube.
IQ.
Y cube. Now x is 4, y is 4. Okay. So 128 by 4 cube into 128 by 4 cube minus 1. Obviously, this is greater than
0.
0. What about SSX? That is R. What it is? SSX is what? This is what
128 by x cube.
Greater than 0, sir.
So that is also greater than 0. Okay. So both are greater than 0. It means the functional value will be minimum.
Minimum.
The area will be minimum. So this is area is your minimum. So for what dimensions this will be minimum? X equal to 4, y equal to 4, z equal to 2. Okay? All right?
Yes, sir.
You can see multiply them together.
Yes, sir.
You will get 32 cubic feet. That is what is given in the problem. तो यहां तक किसी को समझ में नहीं आया हो तो बताओ आ गया समझ में सबको
Yes, sir.
पर क्या लिखा है
हाँ
पर वाले ने हाँ ये
4 फीट ये 4 फीट एक्चुअली मैंने एक साथ ही लिख दिया फीट डायमेंशंस भी तो होंगे ना उसके यूनिट मतलब डायमेंशंस के यूनिट भी तो होंगे ना ठीक है ओके
Yes,
Yes,
sir.
sir.
Yes, sir.
yes sir
Okay. So now, so far, we have seen that there is no restriction. Okay, for maximum minima, to find out, we have not imposed any additional restriction. But what if there is restriction? We call it constraint. Sorry, we call it constraint. So then we use what we call as Lagrange's method of undetermined multiplier. method of undetermined right? So what do we mean by constraint? What do we mean by constraint? In other words, restrictions. For example, let us say you have been given a box which is on this inclined plane, right? It is sliding, right? The constraint is that it should, throughout the journey, when it starts from here and it reaches to this point, from A point to B point, it goes, it should remain on this surface only. This is the restriction we are imposing. That is, we are calling it constraint. That on this surface only, this box should be there. Is it okay?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Another example I can take. For example, you have started a factory. You are producing goods out of that factory. Now you have to determine the cost of the goods. So you have to keep cost of the goods uh, as such that it should be compatible in the market. So you are actually producing cost of the goods should be less than a particular value. Okay. So now you have to have minimum cost. At the same time, you have to also remember that that minimum cost should be, yeah, or in other words, if at all there is maximum cost, so maximum cost of the goods should be less than a particular value. So this particular value is your constraint, your restriction, that you are restricting it. Got the point?
Yes, sir.
You are
Yes, sir.
restricting it
Yes,
within
sir.
that it could be, it could go up to say 10 rupees. Your limit is 11 rupees. So 11 rupees से कम होना चाहिए goods का value जो तुम produce कर रहे हो. So this is what it means. Understood?
Yes, sir.
Yes.
So you have
Yes, sir.
employed a restriction over here. Hmm? So now, how does this method work? We have seen just the examples of constraint. Actually, such type of constraints will be there. Now, in such cases, that let us say you have a function. Okay, you have a function, and this function should be extremum, that is maximum or minimum, subject to a constraint, which is given by another equation, g is equal to k. Understand? The constraint is that this function value should be subjected to the constraint g equal to k. So you have two functions now. One is for the two equations now. One is for the function and another is for the constraint. I hope it is clear.
Yes, sir.
So how does this method work then? So for example, I take that this function, which is function of xy, it is equal to 8x square minus twice of y. Okay. And this is subjected to a constant x square plus y square is equal to 1. Means it should be confined within this region. हमको देखना है कि ये एक सर्किल है, सर्किल के अंदर जो ये फंक्शन की जो वैल्यू है ये कहां पर मैक्सिमम है या मिनिमम. Understood?
Yes, sir.
Within this circle, so we have confined it. Okay? Huh? So
Yes,
that
yes,
is
sir.
what is
Yes, sir.
our aim. Okay. So now if I plot it, so you have a circle, which is a constant. All right, and this is your origin, and what is the radius of this? 1. Okay, this is equation of circle. And what is this equation? Equation of parabola.
Parabola.
Right? Fine. So now this should be subjected to this constant, means this should be equal to k, isn't it? This should be equal to k, means the function this 8x square minus 2y should be such that it should be equal to k, because that is the constant, isn't it?
Yes, sir.
Fine. So let us plot it. Let us plot this parabola. So you may get like this. For one kind of k, this is f. Okay. For different values of k, you may get this. For different value of k, you may get this. For different value of k, this is symmetrical actually. Just these parabolas you will get, and one parabola you will get in such a way that it will just touch that particular circle. Okay, this is equal to k, different values of k. If you put 1 2 3 or 0.123, whatever it is, so accordingly you will get different type of parabolas, isn't it?
Yes, sir.
Right? So one particular parabola will be such that it's just touching this particular circle. Now, what Lagrangians say that at this particular point where this function touches this g, this constant, this is constant, this circle is a constant. Okay, so wherever it touches that, that will be either maximum or it will be
Minimum.
minimum, maximum or minimum. Okay, so then at this point, if I draw a tangent, it will touch both this function as well as this g. Is it or not?
Yes, sir.
यदि यहाँ पर मेरे पास एक सर्किल है
Yes, sir.
and this is a parabola, so then obviously at this point, if I draw tangent, it will touch both of them.
Yes, sir.
Alright. So it is touching function as well as it is touching this constant. If I look at the gradient of it, that is normal to it. What is the normal to it? Normal to it will be in the same direction. Normal to the function is this, and normal to the g is also this. This is your gradient. So this is delta f and delta g. The same direction, in the same direction they will be. That is, they are parallel to each other. ठीक है? They are parallel to each other.
How to find gradient, sir?
Gradient we have found out. Partial derivatives. del f del x,
Okay, sir.
del f del y. Huh? So, so this is
Repeat
what.
once again.
Huh?
F है यहाँ ये जो लिए है अंडरलाइन के वो रिपीट अगेन करें.
Parallel, they are parallel to each other. अच्छा, ये वाला
Yes sir.
भाई यहाँ पर यदि मैं एक टेंजेंट खींचूंगा तो ये दोनों को टच होते हुए जाएगा नहीं जाएगा?
Yes
जी
sir.
को भी और एफ को भी.
Yes sir.
ठीक है, यदि इस पॉइंट पर मैं नॉर्मल लूंगा तो दोनों का नॉर्मल एक ही डायरेक्शन में होगा, एफ का भी और जी का भी,
Yes sir.
है ना?
Yes sir.
है या नहीं?
Yes sir समझ गया.
है ना? अब ये तो ग्रेडियंट है इसके. तो ये डेल्टा एफ डेल्टा जी, अब दोनों एक ही डायरेक्शन में है, पर वैल्यू में डिफरेंस किससे आ रहा है इनके? कुछ डिफरेंस है दोनों के वैल्यू में डिफरेंस है. तो डेल्टा एफ is multiplied by some factor lambda into delta g. ठीक है ना? इन दोनों को बराबर करने के लिए हमको क्या करना पड़ेगा? एक स्केलर से मुझको मल्टीप्लाई करना पड़ेगा. मान लो डबल हो गया, 1/2 हो गया, 1/3 हो गया, 10 टाइम्स हो गया, जो भी हो, है ना? तब जाके ये दोनों बराबर होंगे. आया बात समझ में?
Yes sir.
राइट. सो दिस इज नोन एज Lagrange's multiplier. समझ में आ गया? समझ में आ गया?
Yes, sir.
Yes, sir.
Yes, sir.
ओके, डेल्टा एफ इज इक्वल टू लैम्डा डेल्टा जी. तो अब हमको क्या क्या निकालना है यहाँ पर? हमको निकालना है एक्स वाई जेड एंड लैम्डा. ठीक है, ऑल राइट.
Yes, sir.
वी
Yes,
हैव टू
sir.
फाइंड आउट एक्स वाई जेड एंड लैम्डा. सो नाउ आई कैन टेक द ग्रेडियंट एज I told you. So I can write down that this delta f, which is function of x, y, z, I can write down fx, dx, fy, dy, fz, dz. Can I write down it like this? Can I write down it like this?
Yes, sir.
Huh?
Yes, sir.
Yes, sir.
Right. That is constant, so this is equal to 0. That will be equal to 0. Is it or not?
Yes, sir. Yes,
Because
sir.
Yes, sir.
f was constant, तो उसका डेरिवेटिव क्या होगा? 0.
0.
Right. Similarly, delta g will be gx dx. ये कंपोनेंट्स, मतलब ये x के रेस्पेक्ट में डेरिवेटिव, y के रेस्पेक्ट में डेरिवेटिव, z के रेस्पेक्ट में डेरिवेटिव, हम लोग कंपोनेंट्स बोलते हैं, x डायरेक्शन में, y डायरेक्शन में और z डायरेक्शन में. वेक्टर तो पढ़ा होगा ना आपने?
Yes, sir.
So this is the same thing. Okay, so gx gy dy plus gz dz, this is also equal to the same constant.
Yes, sir.
Okay, so this is equal to 0. So it means that delta f plus lambda g. So delta f is fx dx plus fy dy plus fz dz plus lambda into gx dx gy dy gz dz is equal to 0. Can we write down? माइनस प्लस का मत सोचो, या माइनस भी लिख सकते हो, कोई फर्क नहीं पड़ेगा. हमने डेल्टा एफ इक्वल टू लैम्डा डेल्टा जी लिखा था ना, लैम्डा इंटू डेल्टा जी. सो वी कैन राइट ऑन माइनस ऑल्सो, डजंट मैटर. फ्रॉम वेयर दिस इक्वेशन इज कमिंग? दिस इक्वेशन इज कमिंग lambda delta g is equal to 0. Huh? We have written down delta f minus lambda delta g is equal to 0. Isn't it? Is it or not?
Yes, sir.
Yes, sir.
Yes.
Right? समझ में नहीं आया हो तो बताऊं मैं दोबारा?
वो सर आ गया।
आ गया ना, यही तो लिखा था ना हमने। सो इसी
Yes,
को
sir.
हम लैम्डा को माइनस या प्लस कोई फर्क नहीं पड़ता। सो किसी किसी बुक में तुमको माइनस में दिख जाएगा, कोई फर्क नहीं पड़ता, किसी में प्लस दिख जाएगा, डजंट मैटर, एज आई टोल्ड यू। सो अब fx प्लस लैम्डा gx इंटू dx प्लस fy प्लस लैम्डा gy dy प्लस fz प्लस लैम्डा gz dz is equal to 0, right? Or it means that this is only depending on x, this is only depending on y, and this is only depending on z. So these three terms can be 0 only and only when individually this should be equal to 0, this should be equal to 0, and this should be equal to 0. Is it or not?
Yes, sir.
Because they are independent. This is independent of this and this. This is independent of this and this. क्योंकि यहाँ पर सिर्फ x की टर्म है, यहाँ सिर्फ y की टर्म है, यहाँ सिर्फ z की टर्म है। तो ये इक्वल टू 0 तभी हो सकता है जब तीनों इंडिपेंडेंटली 0 हो। क्लियर?
Yes, sir.
यस सर।
Okay, so fx plus lambda gx is equal to 0. Then fy plus lambda gy is equal to 0 and fz plus lambda gz equal to 0. Okay? Alright?
Yes, sir.
यस सर।
And apart from this, we have g, x, y, z is equal to k. Or, है ना ये? That was also there. So let us say this is equation number 1, this is 2, this is 3, and this is equation number 4. This is already given. This is an equation of constant.
Yes, sir.
Okay. So we have 4 equations and we have 4 unknowns. What are the unknowns? X, Y, Z, and
Lambda.
lambda. So we can determine all those from 4 equations. Can we? Can we?
Yes, sir. Yes, sir.
Yes, sir.
We can.
We can. If there are 2 unknowns, then we require 2 equations. 3 unknowns, 3 equations, 4 unknowns, 4 equations. Right? This is pretty simple. So from this we can find out values of x, y, z. And once we do it, so that is your stationary point. So you can find out stationary point. So this is your stationary point. Okay, once you find out. And once you find out stationary point, then we know the method that we can find out maxima or. All right. So in nutshell, I have already given you the details of this one. I hope it is clear.
Yes, sir.
Pretty clear.
Yes.
Yes, sir.
Okay. So suppose if we were given 2 constants, then what would we have done? What would we have done? I am just asking.
So 2 multipliers, sir.
Eh?
We can take 2 multipliers.
2 multipliers. All right. Very good. So 2 multipliers. Then you would have had how many equations?
5 equations.
5 equations. And 5
Variable.
Variable.
unknowns. So we could easily found out that. Okay. So then rest of the thing same. So once our only job is we have to find out that stationary point, isn't it? Okay, we have to find out that stationary point. Once we find out stationary point, then at that point it will be either maximum or it will be minimum. ठीक है नहीं है?
ठीक है
Yes,
Yes,
sir.
sir.
Not convincing. Not convincing. मैं दोबारा समझाऊंगा, किसी को भी समझ में नहीं आया हो तो. I can understand sometimes it may be difficult to understand.
सर
हाँ हाँ
सर
बोलो
टू
बोलो.
सर अगर टू कांस्टेंट दिया रहेगा सर, 2 मल्टीप्लाई कैसे होगा सर, ये समझ में नहीं आया.
2 मल्टीप्लाई नहीं, 2 मल्टीप्लायर्स होंगे. पॉइंट तो स्टेशनरी पॉइंट तो एक ही होगा ना. ये पॉइंट या तो हाईएस्ट होगा या लोएस्ट होगा.
यस सर.
लोएस्ट होगा या हाईएस्ट होगा.
यस सर.
ठीक है,
यस सर.
आया बात समझ में. तो अभी मान लो मेरे पास ये सर्किल था. ये एक मेरे पास पैराबोला था. दिख
यस
रहा
सर.
है? दिख रहा
यस सर.
है?
यस सर, दिख रहा है.
राइट. अब मान लो एक पैराबोला ऐसे भी डाल दिया मैंने. हाँ, ये सॉरी, एक कांस्टेंट ऐसे भी डाल दिया मैंने.
ओके सर.
ठीक है, तो अब मुझे ये पॉइंट निकालना पड़ेगा जिस पॉइंट पर क्या होगा. यही पॉइंट निकालना है ना. यही पॉइंट पर मैक्सिमम और मिनिमम होगा.
यस सर.
Isn't it or not?
ओके सर.
Understood?
यस सर.
We are confining to a certain region ना. तो यहां पर जो भी पैराबोला आकर के यहां मिलेगा वही तो होगा. So then your function is 1. ठीक है. और ये मेरा ये भी कंस्टेंट है एक्चुअली, नॉट फंक्शन. So this is function, this is constant, and this circle is also constant.
कांस्टेंट.
Okay?
यस सर.
Right? So in that case one can find out. So हमको क्या करना पड़ेगा इसी पॉइंट पर. तो फिर एक ही डायरेक्शन में ग्रेडियंट इनका तीनों का एक ही डायरेक्शन में होगा.
यस सर.
और तो उसके लिए हमको क्या लैम्डा यहाँ पर प्लस म्यू, यहाँ G1 हो जाएगा, वहां G2 हो जाएगा. G2x यही होगा ना.
यस सर.
आई होप नाउ इट इज क्लियर.
Yes, sir.
यस सर.
Okay, so this method is clear. This Lagrange's multiplier and determinant
Yes, sir.
multiplier method.
सर क्रिटिकल
Yes,
पॉइंट
sir.
निकल गया तो सर मैक्सिमम मिनिमम कैसे निकालना.
कैसे निकाल रहा था अभी तक, कैसे निकाल रहा
RT minus
वही
x
वही
square.
सर RT माइनस एक्स स्क्वायर.
और क्या करोगे.
इसमें भी सेम ही होगा सर. इसमें भी सेम ही होगा.
तो मैक्सिमम मिनिमम कैसे निकलेगा. जस्ट हमने कन्फाइन ही तो किया है उस रीजन को कि इस रीजन में ही घूम सकता है. अब इस रीजन में बताओ कि क्या है मैक्सिमम मिनिमम.
यस सर.
हमने कन्फाइन ही तो किया है. बाकी मतलब तो वही है. मैक्सिमा का मतलब है कि वो सराउंडिंग पॉइंट जो होंगे वो इस मैक्सिमम वैल्यू से, फंक्शन की मैक्सिमम वैल्यू से कम होंगे, है ना. मिनिमम है
Yes,
तो
sir.
सराउंडिंग जो फंक्शनल वैल्यूज होंगी वो उससे ज्यादा होगी. यही मतलब है ना इसका, या कोई और मतलब है?
नो सर.
यही मतलब है सर.
यही मतलब है ना.
Yes, sir.
So this is how one can, we will see in examples actually how to do it.
यस सर. एग्जांपल से और क्लियर हो जाएगा.
Example sir, clear हो जाएगा. ठीक है.
सर एक 2 multipliers वाला एग्जांपल.
जरूरत नहीं है हमको. मैंने एक्चुअली ऐसे ही पूछा सवाल कि ये समझ में आ गया तो 2 भी समझ में आ जाएगा.
यस सर.
Yes, sir.
मेरा कहने का मतलब ये था कि एक समझ में आ गया तो somebody answered it. उसको समझ में आ गया तो उसको समझ में आ गया कि इसको एक और मल्टीप्लायर चाहिए और क्या है ना.
यस सर.
That is
Yes, sir.
I just asked that.
Yes, sir.
Okay, you can have as many constraints you apply.
they want.
हाँ, ठीक है, कोई ये दो की एक ही जरूरी थोड़ी है, हैं? ऐसा भी तो हो सकता है ना, यदि तुम गुड्स बना रहे हो उसका कॉस्ट इतना होना चाहिए, पर साथ में उसका ये कॉस्ट इतना होना चाहिए, है इतने टाइम में बनना चाहिए, यू कैन अप्लाई एनी नंबर ऑफ कंस्ट्रेंट्स ऑन इट, ठीक है, इज इट
Yes,
और
sir.
नॉट? हाँ, कि ये इतने ही डिस्टेंस में सर्कुलेट करना है तो क्या होना चाहिए, तो यू कैन हैव एज मेनी कंस्ट्रेंट यू वांट, you can put restrictions in other words. पर कुल मिलाकर के मेथड यही है. आई होप इट इज क्लियर.
Yes, sir.
Yes, sir.
Yes, sir.
चलो ठीक है, तो एग्जाम्पल नेक्स्ट. मैंने कुछ नोट्स भेज दिए थे कालिदास को.
हाँ सर मिल गए,
सर हमने भेज दिया सर ग्रुप पे।
हाँ, ठीक
मिल गए सर।
ठीक है, उसमें कहीं हो सकता है कि कुछ गड़बड़ वड़बड़ हो लिखने में, करेक्शन कर लेना या मुझसे पूछ लेना.
Okay, sir.
वो हो जाता है कभी कभी, दिमाग कुछ और सोचता है और कुछ और. ठीक है, ओके. सो कल क्लास नहीं होगी, परसों अपने टाइम पर होगी क्लास, राइट?
ठीक है सर.
Thank you, sir.
Okay, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir. Thank you.
हैप्पी रिपब्लिक डे सर in advance.
हाँ, you too. Happy Republic Day to you all.
Thank you, sir.
Good.
Good day. Good day.
मंगल सीनू की पार्टी के बारे में बहुत सुन रखा था, मगर ये पहली बार देखने को मिल रही थी. उस पार्टी में सिर्फ सिंडिकेट वाले नहीं, पुलिस वाले, पॉलिटिशियन, सब बड़े बड़े लोग आए हुए थे. पुष्पा भाऊ ने इतने करोड़ का माल बचाया ना, उसके लिए एक रात में पुष्पा भाऊ सबका हीरो बन गया था.
साड़ी साड़ी पहन के साड़ी आए तो उसको घूरे छोटे छोटे